Okay. So, now, what is linear and what's quadratic? So how do you know if that something is linear and something is quadratic? So for example, um, if I have x and y, -2, 0, 2, 4, and 8, 6, and that's gonna be -3, -5, -3, -7, -11, negative 15, and -19. Versus if I have x and y, let me come up with one. Hold on a second. Versus this one, -2, -1, 0, 1, and 2. 0, -11, -16, -15, -8. Can you tell which one is a linear relationship and which one's quadratic relationship? And can you tell me why you think it's quadratic? And yeah. Okay. Yes.
The left one is a linear equation because it's decreasing at a constant rate.
At a constant rate. Okay, so you know for sure that's a linear. Okay. Now, obviously, I give you two choice, right? Second one must be quadratic. But can you prove that's quadratic? Yes.
It goes from negative to
No. By the way, do you guys know what's quadratic mean? What's quadratic mean to you? Square. Is it proper? Good. Both are correct. Anything that you would polynomial with an x square is going to be quadratic. And anything with just x to the first power is called linear. Now, how do you know the second one is quadratic?
Because it goes down to a certain level and goes back up again.
Yes, but that could kind of happen to cubic as well.
or when it goes to a certain level and it goes back up. That happens for cubic.
It can happen with cubic or quartic. Quartic.
Y-axis.
It doesn't matter. I mean, it can happen with. It can depend on which segment. So if it's something like this, right? If I go and just cut off this part, then I've seen this go up and come back down. All right. So for those, yes.
I was gonna say like for every output, like it would be like -11, -5, +1, +7. For that, like the differences between that is +6.
Ah, Shantae was paying attention in Algebra 1 class. Who's your Algebra 1 teacher? Algebra 2. Miss Shaw. Did she talk about it?
Not really. I don't know.
How do you know this?
I was like going over it with a friend from like Mr. Ollie's class.
Okay, good. All right. That's good. Good, good. Okay, so it's called first difference versus second difference. So with the condition that x has to be increases at exactly same rate. So if you see this, right? If you see this, sorry, that was wrong. If you see so yeah, we are teaching in a slower pace compared to Ollie's class, just because I want to cover certain thing first. I want to cover the most important thing. So I here if you look at -2, 0, 2, 4, 6, and -2, -1, 0, 1, 2, you see that this increment exact same amount. If the x is increased the exact same amount, you can look at the difference between those two values. Now, the difference of each value is going to be, the difference of those two values is going to be -4, right? It's -4. Does that make sense? That's going to be -4, and that's -4. So it's going to go down by 4 each time. And make sure you subtract certain orientation. You can do -3 subtract -7, -7 subtract -1, -1 subtract 15, -15 subtract 19. That is going to be the first difference. If the first difference, so the first difference is called a linear. If something that's here, and here it's going to be -11, right? And from -11 to -16 minus -11 is what? -5, right? And here is, now you want to subtract the same way. So -15 subtract -16 is what? What? Yes, 1. And what's -8 subtract -15? It's +7. Good. So now let's look at it from the second subtract here. So what is -5 subtract -11? 6, right? Sorry. And here to here is what? 6. Wait, hold on a second. You got -5, 1 subtract. Oh yeah, okay, 7 subtract that, 6. So if you have a second difference, means this is a square function. Guess what? What if it's a third difference? Cubic. I'll show you a cubic. That just say x and y. And the very well-known cubic function is going to be -2, is going to be -8. -1 is going to give you -1. 0 is going to give me 0. 1 is 1, and 2 is 8. So from here to here is what? -1 subtract -8 is what? -1 subtract -8 is going to be 7, right? 0 subtract -1 is what? 1. 1 subtract 0 is what? 1. And 8 subtracts 1 is what? 7. So here is 7 subtract 1 is what? 6. This is 0. And this is what? -6, right? So look at the third difference. The third difference is what? 6. Right? 0 minus this is going to be 6. So do you see that third difference is the same? Then this is a cubic. You subtract the bottom number to the first number. I like to subtract from the bottom up because I think that you have to keep it exact same orientations. If you keep it exact orientation, you'll find out, are they the first degree, are they second degree, or are they third degree functions? They can be fourth degree function, but you need a more value for that. You need probably 7 value in order to get that same amount of things to be consistent. So in this case, you know this is a cubic function, which is x to the cube. So first difference, second difference, third difference. Does that make sense? So today I might give you a bunch of data, ask you to figure out, is this linear, or this is quadratic, or this is a cubic? Everybody follow me? Okay. Now, that's that. Linear equation is very easy. So, for example, let's just say today, I open an ice cream shop. Okay, now there's some type of correlation. Do you think what do you think ice cream shop correlation to customer? What's the major factor? Huh?
Heat and temperature outside.
Temperature, right? So we can have said, well, if a temperature is at, I don't know, at 50 degrees, you're gonna have sales of 12,000 or 1200, like that. So this is temperature, this is sales. So let's say this is temperature, and this is sales, right? And at 70 degrees, you got 1600. Right? And you can have, let's say, 90 degree, you can have, what do you think 90 degrees is going to be? If this is a linear relationship. 2000, good. Now, what would this question on SAT? This question will says, can you figure out that what temperature, can you figure out like, at maybe like 104 degree, how much your sales is going to be? Right? So what happened is 104, question mark. Okay. Also, I could ask you different questions too. I could ask you says, well, what temperature is what will be the sales when it's 0 degrees? Right? I could ask you 0 degrees. I could ask you says, at what temperatures nobody's gonna buy ice cream? Right? This is a very hypothetical situation, so maybe not gonna be true. So what temperature would it be? So what kind of things were they asking? So what happened to things with this? So how do I establish this relationship? Well, how do you figure out 104 degrees is going to be?
You gotta figure out how much it goes up by.
Good. So what is that called?
2,280. No, for like 100.
Huh?
For 104 degrees.
Okay, so we're gonna start by talking about what you're supposed to do, right? This is what's gonna be on SAT. With those 2 points, if this is linear, right? This is linear relationship. With those two, what can we find? What kind of information we can find if we give you 2 points on a linear relationship? What'd you say? Slope, good. So what is slope?
400.
So what? It'd be 1600 minus 1200, right? Divide by 70 minus 50. Does that make sense? Is y2 minus y1 over x2 minus x1. So that's the divided of 400 over what? 20. That's equal to 20, right? So slope is 20. Now, what you're going to do is you're actually going to form an equation. How do you think of the equation? Well, it's probably the best is you could use this point slope form. And that's what you're going to use on the exam. So by minus 1200 is equal to 20 times x minus 50. Does that make sense? I use point slope form. Now, can I figure out at 104 degrees now? You can even move to the other side to y equal to 20x minus 1000 plus 1200. And a y is equal to 20x plus 200. Does that make sense? Then I can plug in 104 into here. And that's how you're supposed to do on a SAT. You're supposed to figure out the slope. Always figure out the slope when you give you 2 point and the linear relationship. Figure out what the slope is. Is that okay? And then you can find out what happens 104. So it's just gonna be y equal to 20 times 104 plus 200. I have no idea what is that. What is that?
2,280.
2080, right?
No, 200.
2008.
No,
Wait.
200. 2,280.
2280.
Yes.
I
Yeah.
don't know if that's right. Oh, the total is that. Yeah. So, okay, that's fine. So this is what happened when temperature is at 104, right? What happened when temperature is equal to 0? What is it?
200.
$200? Good, because you plug in 0. So it's 200. So at 0 degree, it's going to be $200. At which temperature that you will not make any cells? What is it? -10. How did he get -10? This means asking for x-intercept. If you think about x-intercept, so you have some type of points, right? You have a 20, 50 is gonna give you 1200. 70 is gonna give you I don't know, 1600. But basically, this is asking where the x-intercept is. So the question can ask you, what is the x-intercept, right? So what x-intercept, that's going to give you -10, because you can set here, you can set 0 is equal to 20x, because y is represented cells, plus 200. So it'll be 200 equal to -20, equal to 20x. And x is equal to -10. So at -10, you're going to have a 0. Is that okay? Now, is there any way I can do it faster because you are taking SAT? Desmos. How would you do this question on Desmos?
For the exact place where it goes to 0.
No. You can take this 2-piece data. I'm going to show you a shortcut. You better be paying attention. You better get your phone out. I'm showing the shortcut. Okay? Go to Desmo app. Take your phone out and then get Desmo app. And this is very important. You're going to press the app button. You're going to press the table. You're going to say 50. And you know how to do math. I trust some of you guys know how to do math. But guess what? Even the people who get a 0 on any of my tests, you got to be able to do this. Because you can get same result as the people who get 100. So this is a cheat code. We're going to type in 2 pieces of data. Did you guys do that? Now we have a data called x1 and y1. We're going to do something called regression. This is on pre-calculus, by the way. You're allowed to use this on regression. You're allowed to use this on Desmos now. Because first, they're allowed to use Desmos. Second is you're able to use regression. Pay attention. You know y equal to mx plus b, right? Everybody knows y equal to mx plus b. Except this time, I don't want to call it y equal to mx plus b. I want to call y1 equal to mx1 plus b. Now, instead of say equal sign, I'm going to use the tilt up button. So, tilt up button is right here. You're going to click ABC, and you can click this small like fish line question right here. Do you see that? But before that, you must type in y1. Sorry, I'm going to go back to typing y1, because you're going to use that data to extract the equations. Use that data to extract the equation. M x1. Why do you want x1 and y1? Because you want to use the data that I'm giving. Plus b. So guess what? I'm gonna base on this data. Sorry, I'm gonna base on this data is gonna be negative 30 to 100, and this one is gonna be negative 200 to maybe 2000. So those two pieces of data right here, they're able to generate a line that's going to do that. So just retyping that line. They already have m is equal to 20. So y equal to 20, x plus 200. Right? Guess what? If you want to find out at which temperature you don't make any cells, that's negative 10. Do you see that? You can also see the temperature at 0 degree, you still make $200 cells. Some people just want ice cream that day, even 0 degree outside. As a matter of fact, you can actually click on the table right here and you can plug in any value. 104, 2280. Are you guys following all this? You understand? This is how you cheat on SAT. Because they give you decimals. You gotta learn how to use it. You have a regression. You only need a 2 point to form a regression. But on the pre-calc, they give you multiple points. You got to plug in all the points in there. Why you had to plug in all the points in there? Because the m is not going to be exactly like integer in this case. This y-intercept is going to be some type of decimal. So the regression is making all this data and create a line that go into all this data. Okay, so that some data point is going to be above, some data point is going to be below. Is everybody following me on that? This is a cheat code. Matter of fact, you can use this on quadratic regression. I'll show you. Remember that piece of data I give it to you? Remember that piece of data I gave it to you earlier? Did anybody have that copy down?
Yeah.
Okay, so can you tell me that data? So
X negative 2.
hold on a second. I'm gonna go down here. I'm gonna create a bunch of data. So I'm gonna add point. I'm gonna point here. I'm gonna do -2. -2, I think is 0.
Yeah, negative 0.
-1 is what?
Negative 11.
-1 is a what?
Negative 11.
-11.
0 is negative 16.
0 is -16.
And 2 negative 15.
2 is
Wait,
-15.
1. Yeah, 2.
And the 3 is what?
Negative 8.
-8.
I wrote them off, so I'm sorry. 2 is negative 8, 1 is negative 15.
Oh yeah, you're right. 1 is -15. 2 is what?
Negative 8.
-8. And I'm gonna do it to here. Now, do you see that there's a parabola there going on? Do you see the parabola going on? We're gonna get rid of this line so you don't get confused. Do you see a parabola going on there? You see that there was a parabola? Do you know what quadratic equation is? Write it down if you don't know. So in here you use y tilde mx1 plus b, right? This is gonna give you a linear regression. We're gonna show you how to do quadratic. Well, what is quadratic? Y1. Well, quadratic is gonna be something x squared plus something x plus something c. So a, b, and c. So this one is gonna do what x1 and x1 because you gotta use the data. Well, in this case, probably x2 because we're gonna use the second piece of data. The first piece of data is no longer there. So I'm gonna go to here. I'm gonna say, okay, it's gonna be y2, right? and it's gonna be tilde ax 2, sorry, 2, and then square plus bx2 plus c. Do you see? It creates an equation that go through every single point. But you have to know is this is called quadratic regression. You want to try it? Look at this. If I type in this, if without a point, if I just type in this, if I just type in 3x squared minus 2x minus 16, guess what? It wouldn't do all 3 points. By taking the data, you can recall what the equation is. Got it? Okay, so let me give you a piece of data. See if you're able to get it. I'm gonna give you quadratic. So, are you guys following me or no? Okay, so I'm gonna give you this piece of data, and you're gonna tell me what will be the equation. Okay, this piece of data is going to be, and this is a quadratic, by the way. I'm gonna give you x and y, -2, -1, 0, 1, and 2. -27, -12, -5, -6, -15. Also, by the way, how do I know this quadratic? Because what you're gonna do on pre-calc, you're gonna run down the choices. You see, this is obviously not linear. So besides linear, you can do quadratic, right? So we're gonna take the bottom number is subtract this way. -15 minus -6 is gonna be what? What is it? -9, right? And what is the -6 to -5? Subtract -5 is -1, right? And -5 subtract that is gonna be 7. And that's gonna give you what? -12 is gonna be 15. And if you subtract this way, it's gonna be what? 8, right? It's -8. Yeah, -8. And -1 is -8. And this is -8. Now, if I give you a data table, I don't have to tell you I don't have to tell you are they linear, quadratic, or things. You can look at the differences and you can decide what is it. Got it? Okay, so I want you to figure out the equation of this using the decimal. This must be some type of quadratic equation. You gotta figure out what will be that quadratic equation. This is how powerful decimals can do it. You can find x-intercept, y-intercept, you can find anything about this function. So you gotta learn how to use your decimals. And even you know how to do it by hand, you're gonna do it on decimals, because on by hand you're gonna make mistake. Like I have Anthony, the one, he got 790 on math, but he said I did everything on decimals. He said I don't trust myself to do it by hand, because if by hand I'm gonna make simple errors. by calculator, I'm not gonna make simple errors. If you don't know, if you know how to do it, help other person how to do it. Make sure everybody knows in this room. It can be linear, could be quadratic, could be anything.
Which is plus the negative clock, right? You should not play the X and Y. And then you can put this. Make sure it's A. And it gives you like options. I just
Do they have a quadratic equation on it?
yeah.
Let me see.
You just like press this thing.
Figure that out.
And it gives you options.
I was thinking, how do you teach me something new today? How do you do it? You click here.
You just like press that.
Figure it out.
Oh, but this, they don't have that on the iPad one.
Yeah, you need it.
Do they?
It didn't like work.
You go to the table.
It didn't take off. No.
See, they didn't have that. Wait, hold on.
Try to-
It does
Oh, yeah. Do?
on iPad.
Yeah, it'd be like this.
You click on the chart.
Yeah.
Oh,
wait.
It doesn't.
You like go here.
But on the phone it does. Hold on.
Yeah, you gotta do that for the Y too.
So let me try to do it on the phone.
I didn't do it yet.
Table.
You do that for the C as well, or just the?
No, see, it doesn't have an X. So you
So 2, 5, 3, 10. Okay, so I hear. What do you do?
Oh, I just. You don't have it on your phone, I guess. I'm using the website, by the way, if that makes a difference.
Oh, I see.
Let me see. The app's different.
I didn't get that. Mine's like 3 and all, not 13.
You see, this one does.
Yeah.
Okay, so Lyndon posts something says if you use the web-based version, there is a something on the side. You can choose linear regression, quadratic regression, exponential regression, logarithmic regression, power regression, logistic regression. You can choose that. However, I will prefer you do it this way. There is a reason because we don't know which version of Desmos they're gonna give it to you. Do you see what I'm saying? Because obviously the web version has that, the phone version, the app version does not have that. So thank you, Lyndon, for teaching me something new. But web version does have all the regression built in. But in this case, I don't know if the AP exam they're gonna give you the right one, or you gotta be. So I would prefer you do it this way. This is me. I prefer you do it this way. Did everybody get it or no? Using this way, using tilde. But if they give you the other way, that's even better. Then you don't have to do thing. And I think that it's a one thing is bad is because they're probably gonna increase the curve on the AP pre-cal. Or decrease the curve. Because everybody just press a button and it was the things right there. Okay, so use the regression thing. Knowing what's the equation. For me, I still need you to know it's ax squared plus bx plus c. Now it's cube. How do you do cube? It'll be ax to the cube plus bx to the square plus cx plus d. So it's called standard form. Do you see what I'm saying or no? Are you guys lost? Anybody's lost? Raise your hand. Which part you lost?
Like how you put it in Desmos. like the quadratic regression thing.
Okay, quadratic regression. You know the quadratic is this, right? So you just have to figure out where the button, this button is. So you're gonna go to here. So I have this piece data. We know we use an x2 here, so we're gonna use an x2. So we're gonna use y. Oops, my bad. I don't know what just happened. Something just happened. Great. I'm gonna have to type all that in. So I'm gonna use the app version from the iPad, which is they don't give you what London show if you use a web version of it. So I'm gonna be plus -2, -1, 0, 1, and 2. And this one's gonna be -27. And this is gonna be -12. This is -5. This is -6. And this is -15. Is that okay? Now I'm gonna now on the regular web version on the side of 1 here, there was a button you can click, it will show regression. That's only in flat, but I think they're gonna give you this version. I don't think they can give you a web-based version because they are modified a little bit. So especially you're not gonna want to take a chance. You're gonna say y2, like why is y2? Because the data table, oh, and here's y1, sorry. In data table, we name it as y1. And we're gonna click on this tilde button. It's right here. Do you see this tilde?
Mhm.
And then it's gonna be a x1 square plus b x1 plus c. And you see that they give you a, b, and c value. You got it?
Mhm.
And so everybody got it. If you have a question, now is a good time to ask because your next week is VSAT. I want you to actually use all those tools I teach you. Do not rely on your calculation. Doesn't matter how good your calculation. Doesn't matter you got 100 or 150 on my test. It doesn't matter. Or you got 0. You can all do this. That's going to increase your SAT score by 20, 50 points minimum. You just have to know what kind of regression is it. Samuel, you got it?
No, I think I put in something else. Oh yeah, I got it. What is -4?
It's okay. Now remember, I'm gonna write down what the regression goes on decimals. It's gonna be y1 equal to mx1 plus b. This is a linear. Sorry, not equal. It's gonna be tilde. It's gonna be tilde. Okay. Y1 equal to ax was not equal to tilde of ax1 squared plus bx1 plus c if it's a quadratic. Y1 of a x1 to the third plus bx1 to the second plus cx1 plus d. This is a cubic, and so on and so on. Hopefully you understand the idea. Is that okay? I wonder if they do absolute value regression, which is there's no such a thing as absolute value regression, but they probably can come up with it. I'm gonna try it right now. That just do -2 is gonna give you I'm gonna do 3 2 1 and then 2 and 3. I'm gonna try that, see if it work. I'm gonna try to see if they can come up regression y1 tilde absolute value of x1 plus k plus c plus h plus k, or minus h minus k, minus h minus k plus k. Oh, it does. H is 0, k is 1. Yeah, it does. They can even do quadratic regression, absolute value regression. So we're going to talk about absolute value in a second. So I just try it worked. So you had to know what a tilde button is, because it doesn't have absolute value regression in term of decimals its own. So they can actually give you all that. Is that okay? So that kind of teach you a lot of question on a SAT and pre-calc. So let's talk about how to graph those two functions. How much time I have? 2 minutes? Challenge accepted. Y equal to, did I talk about this graph before? Absolute value of x? I did? When? Last week? Okay. So this one is basically is gonna be this point, this point, this point, this point, this point, this point, this point. Okay, tomorrow we're gonna talk about transformation of this. Y equal to x squared is gonna look like, make sure you understand that it's gonna be a U shape rather than V shape, and has to remember this coordinate. So I need you to remember this coordinate. Like that. This point is called vertex. And this line is called axis symmetry. And this is the axis symmetry. Domain is going to be negative infinity to infinity. Range is going to be from 0 to infinity. Domain is negative infinity to infinity. Range from 0 to infinity. Is this even or odd function? Is it even or odd function? What is it?
Thanks for another great Titan day. Students, you are now dismissed.
We're going to talk about transformation this tomorrow.
Oh, it's